This is Vijay Jyotish with a targeted engineering intelligence advisory on NASA's Artemis 2 mission, the first crewed SLS-Orion lunar flyby. In my previous advisory, I specifically flagged the NET February 6, 2026 launch window as high risk due to conditions that could amplify technical anomalies during critical sequences. That forecast has now been confirmed. The wet dress rehearsal has been delayed to no earlier than February 2nd due to Arctic cold snap impacts on cryogenic preparation and ground systems. As a direct result, February 6 and 7 are no longer viable, and the earliest opportunity is February 8, 2026, from 9:20 p.m. to 11:20 p.m. ET. This real-world delay, driven by cryo handling sensitivities and weather constraints, aligns precisely with the elevated risks I outlined, including prolonged holds, propellant management challenges, and thermal equilibrium issues. It demonstrates the value of proactive risk identification to avoid costly iterative testing. This advisory is specifically focused on the February 8 window and assesses layered technical risks for this exact opportunity based on historical SLS-Orion test patterns, countdown rehearsal outcomes, and recent pad weather events. Probabilities reflect manifestation likelihood if the launch proceeds in this slot. Section 1. Mission Status Recap. Artemis 2 Configuration. SLS Block 1 with core stage cryogenic loading, 700,000 gallons LH2 LOX, RS-25 engines, boosters, ICPS, and Orion for 10-day free return trajectory. Critical interfaces remain: propellant management, fill, bleed, replenish sequences, electrical power handover, umbilicals to batteries, structural pressure integrity, thermal equilibrium, and telemetry sensor chains. The recent WDR delay highlights ongoing vulnerabilities in cryo handling and external constraints that could carry forward into this window. Section 2. Prioritized engineering anomalies with probabilities for February 8 window. Here are the top risks, ranked by estimated manifestation probability in the February 8, 9:20 to 11:20 p.m. ET window. 1. Bureaucratic and review-related delays, holds. Estimated probability, 90%. Prolonged ground readiness reviews, repeated go, no-go polls, range safety, weather holds, or management-level scrutiny extending timelines. The recent WDR slip, cold snap forcing February 2nd tanking, exemplifies this. Multi-day impacts from external constraints or integrated system checks could spill into February 8 prep. 2. Structural, pressure, hatch seal anomalies. Estimated probability, 90%. Hatch pressurization inconsistencies, tank dome integrity concerns under cryo loads, seal leaks, or micro cracks detected in final pressure checks. These represent hidden obstacles at the core of the launch vehicle, persistent underlying integrity vulnerabilities that can manifest suddenly as crises in vehicle health or structural stability under sustained stress or thermal cycling. Such core-level issues are slow to detect initially, but can trigger immediate, high-priority response, extended inspection, disassembly, or rework if thresholds are breached, posing one of the most consequential risks to mission integrity in this window. 3. Electrical and avionics subsystem anomalies. Estimated probability, 85%. Intermittent power bus voltage drops, distribution faults, wiring harness intermittence, avionics caution warning false triggers, or degraded telemetry during comms/power transitions. Critically, during Orion internal handover, T6 minutes, potential loss of cabin lighting, zoned LED banks dimming, flickering, off, due to undervoltage, short protection trips, or load imbalance. Observable by crew telemetry, historically triggers holds. 4. Cryogenic propellant loading and valve anomalies. Estimated probability, 80%. Extended slow, fast fill durations, valve freeze, stick, bleed, replenish deviations, or thermal gradient issues during chill-down GSE interfaces. The 40 and 30-minute holds are choke points. Recent cold weather amplified cryo prep risks, which could recur if thermal conditions remain challenging. 5. Sudden telemetry sensor data anomalies. Estimated probability, 75%. Ghost, misleading readings from cryo pressure, temperature sensors, structural gauges, or range safety transponders. Nominal initially, but deviating under load, e.g. saturation, ice buildup, filtering gaps. Triggers rapid investigations or hold extensions. 6. Propulsion and thermal management issues. Estimated probability, 70%. RS-25 overheating transients, ignition anomalies, thrust vector hydraulics irregularities, or thermal protection stress. Surge events in high flow paths or equilibrium delays before go for prop load. 7. Cabin environmental control interface oddities. Estimated probability, 55%. ECLSS flow deviations, suit umbilical intermittence, or cabin monitoring sensor quirks under integrated stress. Adds troubleshooting load, but not ascent critical. Cumulative outlook, 90% probability of multiple hold extensions, repeated polls, or in-window contingencies if 2 or more categories activate concurrently, consistent with recent cryo, weather-driven delay patterns. Section 3. Key watch periods and recommendation for February 8 window. Immediate monitoring for this window. Final cryo loading and terminal count sequences. Prime for cryo, electrical, structural surfacing. 40 and 30-minute holds. Highest density for anomalies. Terminal count, T10 minutes. Peak cascading risk during power transition and ignition. Iterative attempts on this window carry significant cost. Millions of dollars lost with every scrub or delay through extended operations. Range time, crew quarantine extensions, hardware stand-downs, rework, and personnel overhead. Proactive risk alignment eliminates this trial and error expense entirely. Importantly, a launch in this February 8 window is possible. NASA can make it happen, but it will not be easy. Success in this particular window would require exceptional thorough testing, extreme discipline, flawless execution, and wise, real-time decision-making at every single step. There is no instant victory or smooth path here. The mission would be hard-fought, stressful, and demanding at the highest level. If NASA pulls it off under these conditions, it would be an amazing engineering achievement given the layered challenges and tight margins. But one has to ask, is so much stress, pressure, and risk really necessary when a more favorable window could make the entire process significantly easier, safer, and far less expensive? The smart approach, combining world-class engineering excellence with precise Muhurta alignment, would not only maintain the highest safety standards, but would deliver major cost savings by avoiding prolonged campaigns, reducing the number of test cycles, and eliminating the financial burden of repeated scrubs or extended operations. NASA teams, your execution is world-class. This advisory highlights pressure points for focused mitigation. Pairing engineering rigor with strategic timing can turn these challenges into a streamlined path to success for the February 8th window. Subscribe for real-time updates. Comments. What anomaly concerns you most? This is Vijay Jyotish, Strategic Space and Engineering Intelligence for Artemis 2. Stay vigilant.